Hello, everyone, and welcome to the meetup that focus on debugging. Probably, I assume you are already familiar with debugging. If not, don't worry, I will explain the basics as well. However, I tend to believe that you are going to be surprised a bit with the possibilities that are less popular but still might be very, very helpful when trying to debug our code. Okay, then. So before we start, voodoo, this is the definition. Programming is not voodoo. Just remember, if you develop something and it doesn't work as expected, don't try to fix something and watch it over and then try to fix it by changing something else. This is not the way you want to adopt. Programming is not voodoo. If something doesn't work as expected, if your code doesn't fulfill what you want it to fulfill, use the debugger step by step, find the problem, and fix it. Now, if you know how to use the debugger, most likely that you will find the problem, fix it, and move on. And that would be the fastest path to take. If you try to play around with the code, you waste time. Now, what we're going to do in this meetup is going over the basic stuff and then see some more interesting possibilities. Basically, this is what we're going to do. Okay, so let's start. This is the IntelliJ. Now, before you start working on your code, pay attention. If you go to File, Project Structure, over here, you can control the SDK you are using. And you can also control the language level by which you want the IDE to work. So make sure you are using SDK and language level that fit your expectation. Otherwise, you will get compilation error. So once this is behind us, we can start our development process. We can start coding. And now pay attention to something else. When using an IDE from JetBrains, when you run a program, basically you can either run or debug, and I will explain the differences. Before you do it, pay attention to the fact that you can configure the way the program will run. Now, if you go to run and then check the edit configuration, you get to a screen where you can configure the current configuration you are using. Now, the current configuration has a name. This is the name you can see over here and also over here. Now, something that beginners mistake with, they create a simple program and then they go and press the button to run it. And they forget that actually what will happen won't be executing the code they wrote. It would be executing another code in according with the configuration you see over here. Now, in order to execute the new program, either you go and create the configuration by yourself, or you can ask to execute this specific program right-click the mouse, run demo, and then a new configuration will be created. Its name would be the name of the class, and you will see the name over here. So you can now go over here to edit configuration and configure this specific configuration, this specific running. You can specify arguments you want to pass over. You can change lots of things actually. So this is how it works. There is a configuration, there is the current configuration. You can always introduce changes, and this is a configuration by which you can either run or debug. Now, what is the difference? If you choose to run, then the code is running. If you choose to debug it by pressing this button, then the code will start running, but it will stop at the first breakpoint. Now, what does it mean having a breakpoint?
I guess it runs a different executable, right?
Sorry, what do you say?
I guess that when you run or debug, they run different executable.
No, it is the same program. You either debug it or run it. And it is the same configuration. You can either use it to debug or to run.
So it's not like in Visual Studio where it creates two executables, one for debug and one for running.
Ah, no, it's different. It is simpler. It isn't as you remember from Visual Studio. No. Look,
Okay, thank you.
I press the breakpoint over here, and now instead of to run, I choose to debug. Either running or debugging would be in according to the current configuration, a specific JDK, specific arguments that will be passed over, and so on. So now I place the breakpoint, and when pressing debug, you can see that the execution is stop in this specific breakpoint. Now you can see that just by placing the mouse on top of variables, I can see the value of each one of them. Now on the bottom, we have a window where we can see the variables that currently exist, but we can also add what we call watches. Just right click the mouse, new watch, and specify what is the expression you want to watch after its value. For instance, I want to check whether A is smaller than B. Okay, this is something I'm interested at. So you will always see the value of A smaller than B. Now, if I press this button, resume, it means that the code will continue to execute till the next breakpoint. And if there is no such thing, a next breakpoint, it will continue executing till the program ends. So let's resume. And now let's make it a bit more interesting and add a simple method. Okay, now instead of doing this calculation, I will call the method and pass over the two values. Now let's press a breakpoint. Now, when I press debug, it will start executing and it will stop at this line. Now, we have either the option to enter into the code of sum and see what happens inside that function. We do it by choosing the step into. Look at the bottom left when I press the mouse over here, step into. Or if we don't care about what happens inside sum, we can choose step over. If I click step over, then sum will execute. Something will be returned back into C, and I will find myself moving forward to the next line. Now, remember, when you see a line marked with blue, it means this is the current line that is about to execute. So now I have the two options to choose from, either to step over and then I just move forward and something was assigned to C. This is the value that Sam returned. Now I can resume and finish the program, or I can select step into. So if I select step into, I will find myself inside Sam. Now, when that happens, I can debug the code inside Sam. I can also see on the bottom left what we call the call stack. We were in method main and then we moved to method sum. Now this is a simple stack. Let's make it a bit more interesting. Let's say that we have the method A, and when calling A, there is a call to B. And this is what happens in B. Now, if I place a breakpoint, for instance, over here in line 17 and press debug, meaning we want to start running the program and debug it, look, the stack. This is the call stack. We started in line 5 at method main. We moved to method A in line 8, and then we moved to method B. And in method B, we found ourselves moving to sum, to the method sum. Now, you can always regret and choose to go back by doing what we call a frame reset. Look, if I choose A, right click and choose reset frame, I will find myself going backward. So when you debug your code and suddenly you want to go backward, you can easily do it by choosing frame reset. Let's put another breakpoint over here in line 11. Now let's resume. Resuming, I just remind, means that we want to continue till the next breakpoint. So here it is. Now we are in line 11. Now, something interesting, very useful when you debug the code, and usually when dealing with huge amount of code, and you want to, during the debugging, you want to move forward to a specific line, then what we can do is what we call run to cursor. You see this arrow? I just need to put the mouse on the left part of the line, and then I can find run to cursor, meaning I can easily click the mouse and move forward, doing all the code till that specific line where I chose to do the run to cursor. Okay, then. Now, let's stop the debugging. Now I want to talk with you about, well, this is the basic stuff. Actually, this is what most developers are well familiar with. And let me just summarize. We can do what we call step into in order to go inside a specific function. So if, for instance, over here in line 13, we have a breakpoint, we use the debugger, we can choose step into, look at the mouse on the bottom left, and then I will find myself debug the code inside SAM. Or if I'm not interested in doing so, I can choose step over, meaning I want to execute sum without going inside the code of sum. A value will be returned, and I will find myself in the next line, line 14. So this is the basic stuff. Now, um, let me stop. And then now I want to explain about what we call conditional breakpoint. You see, this is a breakpoint, simple red circle. Now, if I right click, I can configure that breakpoint. I can even click more, and then I got lots of possibilities. But let's start with something simple first. So we have a breakpoint over here. I right click, and let's talk about the condition we can set. So let's say I want to stop the execution, but only if A is bigger than 100. So I put A bigger than 100. Then I press done. Now, if we look at the code, if I try to debug, as you can see, uh, the debugger didn't stop because this breakpoint is a conditional breakpoint. And as you can see, only if A is bigger than 100, then the execution will stop. So now let's change the value we pass over. And now let's try again. And now you can see the breakpoint worked. This is very useful. You write your program, you have a breakpoint in a specific function, and you want the execution to stop at on that breakpoint, but only in specific cases. So you can write a condition that apply for those cases. And then the debugging it becomes faster because then you find yourself debugging the specific scenario you were thinking about. Okay, then. Now, now I want to introduce the smart stepping into, not just stepping into. Remember, we have stepping over and step into. Now, there is a variation of step into. We call it smart stepping into. Let's imagine that we have, let me think about, okay, we have another function that its name is multiply, very similar to sum. Now, over here, oh, you know what? I can remain with A, B. And here inside B, we have a call to sum, but what we pass over as the first argument is what we get back when calling multiply, passing over 3 and 6, and over here, let's say calling sum, passing over 7, passing over A and B. Okay. So if I place a breakpoint over here and start the debugging, now you can see that in line 13, we have a call to the function sum over here, but we also have a call to multiply and also have a call to sum. So what we can do instead of just doing stepping into is go to run, and over here we have debugging actions. And over here we have smart step into, or we can just use the shortcut you see on the right. When doing so, we can then use the arrow keys in our keyboard in order to select the exact call, the exact function call we want to step into. So let's say that we want to step into multiply. Now I press enter and voila, I'm inside the code of multiply. Might be Very, very useful. Okay, let's move forward. I want to introduce what is called method breakpoint. Well, a simple breakpoint is a red circle. A method breakpoint look like this. A method breakpoint is a breakpoint for a specific method. Now you can put a condition, you can configure it. The meaning is that whenever this method is invoked, then the debugger will stop and it will be possible for us to get inside and see what happens in that specific method. Okay, next. We saw adding watches. Look at the bottom. You see that now I'm inside multiply. A, its value is 3. B, its value is 6. Line 21 is marked with blue, meaning that this is the line that is about to execute. Now I can right click over here, you see A equal 3, and go to the set value option and change the value of A. Now, when we continue with the debugging, A now has a new value. So you write a program, something goes wrong, you debug the code, you inside a specific method, and you know that the problem happens when the value of A is very, very big. So just change the value of A and see what happens. Might be very useful. Um, Next, let's move to the other program I created before the meetup. Look at this program. It's a simple linked list. We have int node, we have int list, an object of the type int list represent a linked list. And over here, I create int node objects connected with each other and then create the linked list of those nodes. Now, look at the methods we have over here inside int node. We have get next, get value, set next, and so on. Now, what we can do when we set a specific breakpoint, like let's say a method breakpoint, whenever get next is invoked, I want the debugger um, to show up. Look over here. When I press more, I have filters. For instance, we have the instance filter. I can specify the specific object that when get next is invoked on, only then the method breakpoint will work. Okay, so take a look at the code. What does it mean specifying a specific object? So allow me to place a small breakpoint over here. Now I start the debugging. Remember what I explained at the beginning? I need to select the configuration I want to use. So the configuration I'm now about to use is the program configuration. Here I can see the configuration that are currently available. So I want to use the program configuration, not demo that I was using when writing the simple program demo.java. So I change here to program. I press the debugger button and look what happens. The execution stopped at line 20, and you can see that A, B, C, D, and so on, these variables, each one of them holds a reference for an object of the type int node. Now, when you look at the debugger, you can see that the value it shows as the value of the variable A is int node at, and then there is a number. Now, in the real world, when the code is executed, A simply holds the reference for an object of the type int node. Now, Many students, many teachers also are not accurate and explain that A is kind of a pointer that holds the address of the int node object that was created. In Java, variables cannot hold the address of an object because it is not like in C++. In C++, the code is executed on the operations through using the operation system on the computer itself. In Java, as well as in many other programming languages, the program is executed on top of a virtual machine. So we don't have access to the memory, so it is not correct to say that A holds a pointer or an address. A holds something that looks like an address, but it's not the address. The virtual machine simply maintain a table where each a reference has next to it the address itself. So A actually holds the reference. But when using the debugger, we see something else. We see the name of the class the object was created from, and then there is a number. So we can see that the last node um, is the node that F holds its reference, and the number is 863, you see? So I can go over here to get next, and then specify in the instance filter the number 863, like this. Done. Now, when I continue I can press resume. As you can see, this is breakpoint. Let's take that away. And I press resume. And here it is. I find myself inside get next. But in that specific moment, when get next is invoked on the last node that I specified the number that identifies it, 863. So when you work with linked lists, binary trees, a huge graph of objects, and you want the debugger to stop in a specific method when it is invoked on a specific object, what I've just demonstrated can be very useful. Okay, we have maybe one more minute. So the last thing I want to show is that when you configure a breakpoint, look at this option, thread or all. Now, what does it mean? It means that if you wrote a program that has multiple threads, and here you specify all, then when this specific breakpoint stops the execution, all threads will stop as well. If you select thread, then it means that only that specific thread where the breakpoint stopped the execution, only that specific thread will stop. The other threads will continue. So if you are already have some experience, if you already have some experience working with multiple threads, then you probably know that it is very difficult to overcome problems using the debugger. And usually we use logging messages. Um, what I have just shown might help a bit. I don't say that using logging messages won't be required anymore. I doubt, but still, what I've just demonstrated can be very useful. Okay, then, so this is it. And now questions that you might have, please. Okay. Um, okay, then. So if you don't have any question, then we close the meeting. And that's it. Just take a look. There are more meetups about other topics.
Thank you.
Thank you, Michael. It was very interesting and I learned something new. I appreciate your time and your willingness to share it.
Great.
Thank you very
Excellent.
much.
Thank you and have a great day and good luck. Bye bye.
Bye bye. Thank you.
You're welcome.